We haven't found any alien life out there yet, but it's possible we're just not looking in the right places. There's a team of scientists, part of something called Project Hephaistos, which was set up to look for Dyson Spheres. The team of scientists was recently looking over photometric data of millions of stars. After filtering these objects, they found 7 stars in the Milky Way Galaxy with excessive infrared radiation that couldn't be explained. The next step is to do some optical spectroscopy, which will give us more details about these stars. Could they be Dyson Spheres? It's still unclear whether this is the case, but the big question is, could an alien civilization really build a Dyson Sphere around their star? And if so, how would they do it? The Kardashev scale is a way of measuring advanced civilizations based on their technological capabilities. It was created in 1964 by Soviet astronomer Nikolai Kardashev. It's a serious scientific framework for understanding the different levels of technological civilizations, including our own. One thing is clear: human technology is advancing rapidly. Given how quickly AI is advancing, it seems we're on the brink of a major technological shift. The Kardashev scale offers a roadmap to the stars and beyond. So let's explore the different types of civilizations and the mind-bending possibilities they represent. Identify where we need to be on this scale, and look at what we need to build a Dyson Sphere. Although it wasn't part of Kardashev's original scale, many scientists now include Type-0 to represent our current state. We're still a pretty limited civilization, tied to our home planet, and we're only just starting to tap into the full potential of our world. When you look at what we're doing now, it's not really that advanced. We burn fossil fuels, we've started using wind and solar energy, and we've just begun to tap into nuclear power. Despite all this, we're still vulnerable to things like planetary disasters, climate change, and the depletion of our natural resources. We've only reached out to our closest celestial neighbor, the Moon, although we have sent robotic spacecraft to other planets. When you look at all this, it doesn't seem like much yet, but we are a civilization on the brink of greatness. Our rapidly growing technology shows that our species has huge potential. As we speak, scientists are working on fusion reactors that could revolutionize our energy production, while visionaries are dreaming up some pretty out there ideas like space elevators and Dyson Spheres. The leap from Type-0 to Type-1 is probably the most crucial in our evolution. It's a transition that presents a lot of challenges, requiring us to overcome our tribal instincts, unite as a species, and learn to manage our planet as a single, sustainable system. If we can do that, we can move on to the next level. As we move up to the first official rung of the Kardashev scale, we start to enter the realm of science fiction. A Type-1 civilization has mastered its home planet, controlling and harnessing all available energy. Just picture a world where we can control the weather whenever we want. We could stop hurricanes in their tracks and even send rain to dry areas. Imagine vast solar arrays covering deserts, wind farms spanning entire mountain ranges, and a global network of fusion reactors providing clean, limitless energy to every corner of the globe. A Type-1 civilization would have the power to reshape continents, create new land masses, and even start terraforming other worlds in their solar system. They'd have complete control over their planet's resources, recycling and repurposing materials with amazing efficiency. But there's more to a Type-1 civilization than just energy. They'd probably have achieved a level of global cooperation and governance that seems utopian by our standards. Wars over resources would be a thing of the past, replaced by collaborative efforts to push the boundaries of science and exploration. The technology of a Type-1 civilization would be incredible. Artificial intelligence would be integrated into daily life. Nanotechnology would revolutionize manufacturing and medicine, and the first steps towards true space colonization would be underway. Despite all the amazing advancements, a Type-1 civilization is still confined to its solar system. The vast distances between stars remain an obstacle, but that won't be the case for much longer. If a Type-1 civilization represents mastery over a planet, a Type-2 civilization extends that dominance to an entire star system. This is where the lines between reality and science fiction start to blur significantly. A Type-2 civilization uses all the energy that its parent star produces, and that's where the Dyson swarm or sphere comes in. While it's unlikely that a solid sphere would work, a swarm of satellites or a ring-like structure could serve the same purpose. With the power of a star at their disposal, A Type 2 civilization would be capable of achieving things that would seem godlike to us. They could move planets at will, maybe even to escape the eventual death of their star. They could even create artificial habitats the size of planets, offering living spaces for trillions. They might even achieve immortality. With their vast energy resources and cutting-edge technology, they could conquer aging and disease and start transferring consciousness to artificial bodies, such as robots or even pure energy states. Interstellar travel, while still challenging, becomes a realistic prospect for a Type 2 civilization. Generation ships or advanced propulsion systems could allow them to send colonies to nearby star systems, marking the start of their long journey to expand their influence beyond their home system. The computing power at a Type 2 civilization's disposal is almost beyond comprehension. They could create simulations that look just like reality and maybe even spawn new universes. The distinction between the physical and the virtual would become less clear-cut, opening up a whole new realm of possibilities. Even at this level of advancement, a Type 2 civilization would still be largely confined to their local stellar neighborhood. Even so, the vast distances between galaxies would still be a significant challenge. But for a species that can harness the power of a star, nothing is impossible. At this point, we're really talking about the cosmic. A Type 3 civilization has gone beyond just one star system and has tapped into the energy of an entire galaxy. This is a level of existence that is so far beyond our current state that it's almost impossible to picture. A Type 3 civilization would have colonized and made use of millions or even billions of star systems. They'd have mastered faster-than-light travel or found ways to get around the light speed barrier through wormholes or other exotic means. Distance wouldn't mean much to them. The energy at the disposal of a Type 3 civilization is truly astronomical. They might tap into the power of supermassive black holes at the centers of galaxies, extract energy from the very fabric of space-time, or utilize dimensions beyond our comprehension. Given this level of energy and technology, a Type 3 civilization could reshape the structure of their galaxy at will. They could even move stars to create vast engineering projects on a galactic scale. It's even possible they'd create structures the size of solar systems, or larger. It's possible that the beings of a Type 3 civilization have already evolved beyond their original biological forms. They could be pure energy, part of a huge network of AI, or something we can't even imagine. Their consciousness might cover the whole galaxy, making it a huge living superorganism. For a Type 3 civilization, controlling matter and energy would be easy. They could create or destroy stars at will, ignite new galactic cores, or even prevent the heat death of the universe in their domain. They could even alter the very laws of physics with this level of power. Even at this godlike level, there are still higher rungs on the cosmic ladder. Kardashev's scale stopped at Type 3, but other theorists have suggested even more advanced levels that stretch the imagination. Type 4 civilizations would extend their influence beyond a single galaxy, maybe even commanding entire galactic clusters, or even a significant portion of the observable universe. At this scale, they'd be able to manipulate dark energy and dark matter. They might even be able to create new universes, either by inducing local inflation events or by engineering reality at its most fundamental level. Given the level of energy and technology we're talking about here, it's possible that a Type 4 civilization might be the cosmic gardeners, seeding new life throughout the cosmos, or guiding younger civilizations up the Kardashev scale. Some people have even suggested that there might be a Type 5 civilization, one that has control over all possible universes and dimensions. Such a civilization would effectively be omnipotent and omniscient, basically indistinguishable from what we might consider gods. From our perspective on Earth, a young Type 0 civilization just starting out in space, the higher levels of the Kardashev scale might seem like nothing more than a fantasy. But it's worth remembering that barely more than a century ago, the idea of humans walking on the moon was considered pure science fiction. If we look at the Kardashev scale, a civilization that can build a Dyson Sphere would be at Type 2 status. This means that they can harness the entire energy output of their star. While a partial Dyson structure, such as a swarm of satellites, might be achievable for an advanced Type 1 civilization, a full Dyson Sphere would likely require capabilities well beyond our current level. To get a sense of the scale of a Dyson Sphere, it's helpful to think about the size of our Sun. The Sun is about 864,000 miles wide. It's estimated that you could fit 1.3 million Earths inside the sun. If we wanted to build a Dyson sphere around our sun, it would need to be at least 1 astronomical unit across. That's the distance from the Earth to the sun, which is about 93 million miles. That would give us an internal surface area of around 108 quadrillion square miles. That's around 550 million times the surface area of the Earth. Building a Dyson sphere would be an engineering challenge on a cosmic scale. So here's how we might start to do it. The first thing we'd need to do is gather enough materials and resources. Our planet doesn't have what it takes to build this structure. We'd have to get materials from several of our neighboring planets, or even harvest asteroids and comets in our solar system. Mercury could provide a lot of material. The best idea would be the Dyson swarm, using self-replicating robots. One of the most plausible methods for building a Dyson sphere is using self-replicating, solar-powered robots. These robots, which are similar to von Neumann probes, would be essential for a project of this scale. It goes without saying that AI is going to be a key component of these self-replicating robots. The robots would start by building solar collectors and energy transmitters. As we harness more and more energy, we can use it to power more and more construction. The swarm of collectors would gradually expand to encompass more and more of the sun. It's tricky to say how long it would take to build a Dyson sphere, starting with a swarm, because it depends on factors way beyond our current tech capabilities. However, we can make some educated guesses. With current technology, it's likely to take millions of years. But with highly advanced self-replicating robots, it could be done in a few hundred to a few thousand years. The rate of construction would likely follow an exponential curve, starting slow but accelerating rapidly as more of the sun's energy is captured and more robots are produced. Robots would create more robots, which would then build more solar collectors, and so on. Eventually, the solar collectors would start to connect to each other and form a Dyson sphere. The next challenge will be ensuring the structure is gravitationally stable. It would take some seriously sophisticated engineering to keep the structure in place around the sun. The second issue we'd need to tackle is heat dissipation. It would be tricky to control all that energy from the sun at first. It'd be really important to make sure we don't melt the structure while we're managing all that captured energy. We'd need to develop materials that are much stronger and lighter than anything we've seen before. But that's not all. The construction itself would require levels of precision far beyond what we're used to. But this is something that a Type-3 cosmic architect would definitely be able to handle. What are your thoughts on whether humanity could one day achieve this incredible feat? Let us know in the comments if you have any thoughts on this. We did find some stars that seem to match what we'd expect from Dyson spheres, but it's still too early to say for sure that these megastructures are the cause of the strange star behavior. We need to do more observations. It could be space dust, rocks, or something else. Until we know more, we just don't know. Once we've done more research on the data, who knows what we may find? Researchers have discovered a number of unusual objects that challenge our current understanding of the universe, but no evidence of extraterrestrial life. So it seems likely that this pattern of discovery will continue for some time to come, but hopefully, one day it won't. It'll take us at least 100,000 years to become as advanced as we need to be, and it could even take 1 million years to become a Type-3 civilization if we survive that long. But are there actually such civilizations out there? If there are, we'd surely be able to see all that intense technology in space. NASA says we've found about 4,000 planets outside our solar system in the past 2 decades. There should be trillions of stars in our galaxy, each with planets. So why haven't we found any signs yet? This is the Fermi paradox, which suggests that our universe is old and vast enough for there to be other life forms out there, apart from the one we have on Earth. But despite decades of searching, we haven't found anything like that. It's possible we haven't looked hard enough. The ongoing search for extraterrestrial intelligence is limited to catching several frequencies of radio and TV emissions. The problem is such signals could only be made by a Type-0 civilization, and because they also interfere with static charges in space, a good portion of that signal is lost. I think a better approach would be to split the signals into different frequencies, which would help us preserve more of the signal. Unfortunately, if we imagine a Type-0 civilization that only uses one frequency, they won't be able to understand the message properly and will hear nonsense instead. So even if there are lots of different messages from Type-2 or Type-3, civilizations in our galaxy Our Type-0 radio telescopes can't pick them up properly. Another researcher at the National Astronomical Observatory of China has come up with a new theory about where those civilizations could be hiding. A professor and her team scanned a large area of the sky and identified 21 galaxies. They were looking for unusual radio signals to detect alien exhaust, and the two weird galaxies they've discovered had enhanced infrared emissions that couldn't be explained by natural phenomena. The astronomers are hoping that it could point to a bunch of Dyson Spheres in entire galaxies that have been captured by an intelligent civilization or civilizations. But to prove this theory, they need to know for sure what's causing these infrared emissions. There's another way to look at the Fermi paradox. Maybe these civilizations have decided to stay hidden. Our universe is huge, and just because we haven't found anyone yet doesn't mean they're not there. When looking for signs of technologically advanced civilizations, astronomers often look for different types of infrared emissions and waste. But what if a super-intelligent civilization has not only come up with unimaginable technologies, but also found a way to hide its presence? If so, it seems we've been looking for something that isn't there and missing what should be our main focus. If we keep coming up empty-handed when it comes to signs of extraterrestrial civilization, we could try looking at what we're missing. It's more likely that if a Type 3 civilization existed somewhere out there, it would gather all the energy available in a galaxy and exhaust all its power supply, leaving nothing behind. And there are some pretty empty regions in space, the great voids, which were once thought to be signs of intelligent life. But this theory was disproven. While scientists haven't given up hope, most of their studies eventually come to a dead end. If that's always the case, it raises another question. What if we just happened to come into being at the wrong time? One computer simulation suggests that intelligent life could have been more common 4 billion years ago than at any other point in time. It might sound far-fetched, but if simple life forms appeared on Earth around 3.5 billion years ago, why not intelligent life elsewhere in the universe at roughly the same time? And should we really be trying so hard to satisfy our natural curiosity when there's a real threat of possible extermination of the human race? We all come from the same ancestor, and we can't help but get angry at each other. So, should we assume that a hyper-advanced civilization would care more for our lives than we do today? We're scared of exhausting our planet's resources. A Type 2 civilization would be afraid of the death of their star, and Type 3 civilizations would be concerned about how to escape the death of the universe. But if we look at the broader version of the Kardashev scale, for a Type 4 or even Type 5 civilization, that wouldn't be something to worry about. These creatures could theoretically create a new universe. One physicist estimates that the energy needed to give birth to a baby universe in a laboratory would require about 1,000 trillion joules, which is far below the limit of such a civilization's capabilities. While Type 4 civilization is pretty much unattainable, it would literally mean becoming the creators of everything we could ever observe, think, or imagine. Given how quickly we evolve and that we can even make effective tiny laser-propelled spacecraft today, it's possible that we've already been visited in the past. The chances of us noticing their presence are pretty much zero. It's even possible that we're already being observed by a more advanced civilization that's waiting until we've made enough progress to eventually get in contact. Or maybe they've already decided to reach out, but it will take hundreds of thousands of years for them to get here from another galaxy at the other end of the universe.